welcome to Lesson 8 on our series on Unity Fundamentals. This course was designed for the students at Saturday Academy, and I am your instructor, Will Batillo. This lesson, we're going to start adding a bit of complexity to our guard character so that rather than just patrolling around forever, it will switch between patrolling and chasing the player, depending on whether the guard sees the player. Now, one thing I'd like to just make clear, and as I'm running this, is that chasing the player is not particularly difficult. If I just to illustrate that, right now, if the guard is patrolling, all I really need to do is to just swap out this target for the player, and now the guard is going to be following the player. And if I swap back in the follow target, then they go back to their patrol route. So what I really need is to be able to swap out this target dynamically, and for that to be based on whether the guard can see the player or not. So it's going to need some kind of line of sight. So that's what we're going to start building today. So I'm going to go into my scripts, and so last time I created this follow. Now I'm going to create something that's a little bit more general, called or a little more specific, I should say, called a guard AI. All right. Open that up and get rid of these right here, and also get rid of these comments around start and update. I'll keep the methods because I'll be using them eventually. And so in the update loop for the guard AI, I am going to look for the prisoner, and will possibly react in some way. So create a method for that, void look for prisoner. So updates delegating this searching out to specialized methods. Now this look for prisoner will cause the guard to do different things depending on whether it can see the player or not. And so we'll create a little variable right here, bool can see prisoner equals, and then I'll delegate again to a can see prisoner method, which will then create down here. And also one thing you might notice, I'm declaring a Boolean right here inside of this method. So that means this Boolean can only be used within this method, not throughout the entire script, and it will be redeclared and then thrown away at the end of the method. But actually, you know what, come to think of that, I think I'll just bring it over to the method. This would work just fine, and might be better practice in programming generally. However, in game development, caching the variable here is going to use less memory than declaring it every single frame. So I'll put that up there. And now let's get this bool can see prisoner method. And before, I've always been using this void. Now I'm putting a bool at the beginning. So it's time to describe what this little void is for. Methods, when they get to the end, will return something, or they might anyway. And so like here, for example, it can see prisoner, it'll call this method will go through, and at some point it'll return true, or it will return false. And that, since this is a Boolean variable, this describes what's being sent back. Now, in the case of things that are void, it just returns nothing. And that's what void means, is nothing. Either it won't have any return statements, or if it does, it'll just be an empty return, not actually sending any data. In this case, we're actually want to send back a true or false so that this method will resolve to true or false. So anyway, that's a little bit about return types. Kind of a lot like arguments, but just the other direction. So now let's write our can see prisoner method. And for this can see prisoner, we're going to use a sphere cast. let's show you what that is. If I go into Unity and SphereCast, let's get out our documentation here, bring that up, and these are the arguments that it needs. It needs a center where the sphere starts, the radius, the direction that it moves, and then some other things like distance, what kinds of things it can ignore or not ignore. So the way you can kind of think of it is, imagine that this guard just created a little sphere collider, like that. Just like takes a sphere and it shoots it out forwards, and it moves along the line, and then it sees if it hits anything, and then it returns back what it found, if anything. There's also a variation on this called SphereCast All, where it just goes its full distance and returns back everything that it finds. In this case, we'll just return the first thing, which is good because, say, if the player hides behind a wall, the guard won't be able to see it, since we're using SphereCast rather than SphereCast All. So if the sphere hits something that blocks it, then that'll allow the player to hide from the guard. In this, first we're going to see if the guard sees anything, because if it doesn't see anything, then it's going to return false. So if physics.spherecast, and so our first argument is the origin, so that is transform.position. So the guard's going to start the SphereCast at the guard. And then the next argument is radius. So I'm just going to use a variable right here, the vision width, which I'll declare up here. So let's see. Get another serialized field, float vision width. Okay, let's see, our next argument is direction. So that's just going to be transform.forward. So whatever direction the object that this script is attached to is facing, just go forward along the z-axis. Then out hit. So how this works, it's kind of like returning, except that instead of resolving this method into what it finds, it's going to put what it finds inside of this, inside of out hit. And then we'll be able to just use hit dot, whatever features that we need in order to get information about what the SphereCast finds. So you can just think of out as another form of returning. So that out hit was this hit info. Next, we need our max distance. So that will be another variable. So we've got a vision width and vision distance. So we can put that down here. And next, have a layer mask. So we can use this to selectively ignore colliders based on the layer that they're in. And we're not going to bother with that. So I'm just going to put in a -1 here so that it will not selectively ignore any colliders, just to keep things a little simple. And then the next thing is that some of the objects in the scene are trigger colliders. We want to ignore all of those. So for example, if we saw like this button container, this is a trigger. This right now could block the guard's view, and we don't want that. So anything that's a trigger we'll just ignore, and we do that by adding this, filling out this next argument. So here's what we put as -1. This query trigger interaction specifies whether it should hit triggers, and for that we'll type in query trigger interaction dot ignore. So now it'll ignore trigger colliders. Okay, so that's it for that if statement. Oh, one other thing, right now this out hit is going to say that is an undefined variable. So just to declare that, I'll say raycast hit So now it'll know that this hit that it's storing, the output of this sphere cast, it'll store this into a variable of type raycast hit called hit. Okay. So if the sphere cast has found something, then if hit, or the thing that was hit, dot transform equals prisoner, so see if that thing's transform matches the prisoner, then we will return true. And if either of these if statements fail, then we will return false. Now, one issue of style that just to know about, a lot of places will say to put these curly braces on every if statement, and you can do that, but I kind of like making things a little bit more concise. And if you have an if statement or a for or a for each that only has one line, then you can have the option of just indenting it and not putting the curly braces in. Kind of the concept of a curly brace is that everything inside of between them is one statement. And so an if statement will just check, and if it's true, it will execute the next statement. Curly braces allow that to be on multiple lines with so we don't really need that, and so it's just a personal preference. I like leaving those out when I can so that things just take up less space. But you can add those in if it helps you see things. As soon as you have multiple lines, though, then you need the curly braces. Okay, and so that should be all. Now, just to check that this is working, I'll put in a debug.log can see prisoner. Oh, and also this prisoner variable, or this transform, is not defined, so I'll also put in a serialized field of type transform and prisoner. By the way, the reason I'm using a transform here rather than a game object is game object is not stored inside of hit, but transform is, and so is collider. And so you could use either of those. If I wanted to get the game object, then I would have to say hit.transform or hit.collider.gameObject, and so no need to put in that extra work. Okay, so I've got all of that. See if there compiles. Yep, no errors. That's good. Now I'll go to this guard here and throw in a guard AI. All right, I need to open the prefab. Throw in this guard AI. And I'll give it a vision distance, let's say, vision width of, let's say, 5, or let's go with 3. So that's going to be the radius of the sphere that it's sending out. So give it a nice, wide vision. And let's give it a vision distance, let's say 20. And now we can't set the player into this field in the prefab. So I have to get back out of this and then drag in the player when we're in the scene view. Okay. So now run the scene. And I still have this button as being unlocked by default. Okay, and now if we look at the console, we see a bunch of false statements accumulating. And now the guard's looking at the player, and we see this true counter going up. And then once we get out of the guard's view, then it goes back to this false counter incrementing. So this vision is working fine. Also just notice these follow paths are in kind of weird locations, so I'm going to move these back a little ways. Okay, there, and there. Move 1 and 3 inwards a little. Okay, that should be a little easier for debugging. 3 out there. So back in our code, we can see the prisoner. Now we need to actually do something with that information. If can see prisoner then this is where we're going to need to change what it's targeting. So we will deal with that with some Unity events. So I'm going to create right here serialize field Unity event, and I'll call them on angry for when they go from patrolling to seeing the prisoner, and also on calm. And since we're using Unity events, we need to add the library for it using Unity engine.events. Okay. So if I can see the prisoner on angry.invoke, and I'm using the curly braces here because I am going to be adding more lines later. Else, I'll just keep it as an else for now. So if I cannot see the prisoner, then on calm.invoke. Alright, so now we need to say what happens when these events occur. So on the guard, okay, I have these Unity events right now. On angry, then we can just drag in the guard, and this is where we set our follow target to be the player. So go in follow, and okay, and right now there is no method for no way of changing the target. So let's fix that before moving on. So in our follow, I'm going to create another public void set target transform target. And now we can set this dot target, so that is this variable is equal to target, or this variable. Alright, so now that that's in place, in our guard we can look down at follow, and now we have this set target option, and we can drag in the player. Likewise on calm, bring in the guard, follow, and set target, and then back to this follow target transform. So now, go in, leave the door, and the guard is patrolling, and then it sees me, and now it's following me. While we're here, let's add a little bit of a visual cue to see, so that the player knows whether the guard is chasing them or not. It's not just, oh, maybe it's chasing me because it seems to be following, or maybe I'm just aligned with where it's going anyway. So I'm going to change the color of the guard when it can see the player. So for that, we can just go into the model and add a component and go into this color changer, and let's give it two different colors. And for element 1, we'll just set a white full alpha, and element 2 we'll go with red and also full alpha, and give it a starting index of 0. Now on this guard, can add plus for this on angry, drag in the model, go into the color changer, set color to 1, that will be the index of our red color, and then on calm, bring in the model, color changer, set color 0. Okay, and save that. So this will work the same way. It'll still be just as flawed, but now at least we'll have a clearer cue as to what's happening. So now, yeah, now we can kind of see the errors. It just kind of flicks over to red very briefly and doesn't really stay there very well. Now to fix these errors, there's a couple of things we're going to need to change to this code. To start with, I'm going to make it a little bit more predictable. Right now, this look for prisoner is happening every single frame, and one of these two conditions is definitely going to execute. It either can see the prisoner or it can't. This has to be true or false. And that means either this or this is going to be invoked every single frame. And we really don't need that. These Unity events only need to be invoked when there is a state change. So to make these only happen when they need to, I'm going to add a little bit of a state machine behavior into this. And just to keep, the way I'm going to do that is with a enum. So enum guard state, and then I'll just put in patrol and chase. Okay. And enum is essentially a type of variable that you get to define yourself, and you can say all the different things that it can be. So this just creates the enum type. It's kind of like creating a class. And now we're actually going to create a variable of this type. So guard state state. Right now this is only accessible inside of this class. If you want guards other things to be able to view and work with guard state, you could put it up here outside of the class entirely. But we don't really need that just now. Also, if you want it to be visible in the inspector, you can make it public or serialize it if you like. Again, not necessary. Now that we have this state, we can now add some additional conditions here. So if state equals guard state dot patrol and can see prisoner, so that is if I am currently in the patrol state and I can see the prisoner, then we will transition to the chase state and invoke the things that need to happen when the guard enters into it. Likewise, down here, if state equals guard state dot chase and cannot see the prisoner, then we're going to change our state to patrol and invoke all the things that happen when the guard calms down. Now, just to test that this is working as intended, I can just say right here debug.log and entering chase state. Copy that, go down here, entering patrol state. And also to make sure that we're starting in patrol, we'll just add this to start. State equals guard state dot patrol. That way we know what state we're starting in. And this is technically redundant because patrol is the first item in this enum, so that's what it's going to be initialized to. But it's good to be explicit with these things in case we change the order for whatever reason, or like add something at the beginning. So let's test this out, see what happens when I run the game. And now when the guard sees me, I enter the chase state, and when the guard cannot see me anymore, it returns to the patrol state. One thing I've just done, by the way, for debugging purposes, is I've placed the player right next to the guard and set the guard's speed down to, set the guard speed down to 0. So that way I can really control moving in and out. Okay, next thing that I'd like to add here is that if the player goes out of the guard's view, like just manages to escape, that the guard will continue chasing the player for a short period of time before returning to the patrol state. This will make the guards a little bit harder to evade and give them like a sense of having a bit of memory. So to create this delay, I'm going to create a new state, which I'm going to call track, which is that period of time where the guard is still chasing the player even though they can't see the player. So just add to this enum, track right there. And now, so if the state is chasing and they can't see the prisoner, instead of all this, let's comment this out because I'll be using it somewhere else, then I'm going to change my state to guard state dot track. And that's it. Now, if, and also I'm going to start a timer for when I can transition from tracking in back to patrolling again. So I'm going to deal with that right now. I'll add another serialized float right here, and I'll call this track duration. So this is the amount of time that it can stay in that tracking state. And then also I'm going to create a float, a local one that doesn't need to be serialized, called start time. Start tracking time. Be a little clearer in our naming. Now when we've changed to this tracking state, I can now say that start tracking time equals time dot time. So this gets the current time from the system, and that saves it to this local variable right here. Next, add another else if state equals guard state dot track, and I can see the prisoner, then I'm just going to go right back into the chase state. Which won't change the guard's behavior, but if it doesn't see the prisoner again, then that'll reset this start tracking time as it goes back into track. Okay. Now, else if its state is guard state dot track and cannot see the prisoner, then if time dot time, so that current system time, minus our start tracking time is greater than track duration, then state equals guard state dot patrol. So remember, look for prisoner that's being called every single frame, and time dot time is going to increase as time passes, whereas start tracking time will just stay right here unless it gets reset by the guard seeing the prisoner and then not seeing it again. But assuming it continuously does not see the prisoner, this will just stay the same, and so the difference between these two will gradually increase, and eventually it will come to be greater than the time we set in this serialized field, at which point then we can go back to patrol. And actually, I'm going to add some curly braces here, because this is where we can bring all this stuff back. Alright. these braces all lined up, remove the comments. Alright, and I'll keep these console logs in to make sure everything is working correctly. Now go back into the editor, and if I look on this guard, there's this new track duration variable. I'll give it 2 seconds. And now let's run this. The guard is not... So the guard sees me, and I move around, and I move out of its view, and then it goes back to the tracking state. Now, one thing that's causing a bit of a problem is that the guard is not seeing me when I get close. The tracking's working fine. It's just that there's something a little bit wrong with its vision. So what's happening is, if you imagine like a sphere, and that is of a radius of 5, so that's fairly big, and it casts out. What happens if the player is inside of the sphere once it's created? Well, you'd think that that shouldn't matter, that it's still, the sphere still hits it, but apparently not. If the player is inside of the sphere when it goes out, then it doesn't detect it, but if the player is outside and then the sphere goes and hits the player, then it does count, which is really annoying, to be honest, but we can work around that by changing this a little bit. So instead of the sphere starting where the guard is, we're going to have the sphere start back a little bit, so that the front edge of the sphere is right here where the guard is, and no matter how wide it is, the front will still be right here. And then when it shoots forward, even if the player is right in front of the guard, it'll still catch. So for that, I'm just going to modify the origin point. So transform.position minus transform.forward times vision width. Now I'd like to say plus transform.back, but that yields an error. Unity doesn't know what that means. There's only forward, up, and right. And if you want to get back, left, or down, then you just have to use a negative. And then, because I'm multiplying it by vision width, it doesn't matter what the vision width is. The front will always be right where I want it to be. I'll run this again. And now the guard sees me right from up close. And if I evade it by dancing around, it's kind of hard to lose it. Actually, one thing, I'm going to make this a little easier on myself and cut the guard's speed, turn speed, down to 30. Right now I can evade it a little better. So if I stay behind it for 2 seconds, then it loses track of me. And it doesn't see me when I'm over on the side, but then as soon as I get a little in front, then it sees me again. I can try to escape. I go behind, it doesn't see me, but it still's tracking for a little while, for those 2 seconds, until that time elapses, and it goes into the patrol state. And as I can see through these console logs, these transitions aren't happening. They're only happening when they need to. So as a final little touch, I'll get rid of that and those console logs. Well, one other thing you might notice with this prefab right here, some of these entries are in bold and some are not. And actually, I'm going to set this back up to 2. What that means is, if something's in bold on a prefab, that's because it's Unity communicating that the value for this instance is different from the value on the prefab. So if I take a look inside of this guard container and look at these guards, you see this track duration still 0, and and other things like that. So one thing that to make sure that the prefab stays updated, so if I create other guards I don't have a bunch of empty fields, is I can click right over here in Overrides and then Apply All. And now if I look at this guard, a lot of the things that were bold are now in regular typeface. And if I check the prefab, you can see now the changes have been applied. But not all of them. There's still things like player transform is still in bold. And that's because this can't be overridden. Again, it's that thing of player is a scene reference, and prefabs are resources, and so they can't really get access to things that are scene specific. One last little improvement I'd like to make before ending this episode is changing the speed that the guard moves when it's chasing. So when it's patrolling, it goes nice and leisurely, but when it's chasing the player, it speeds up. So for that, I can just add new events right here for this on angry and on calm. And I just want to change this move speed on the move and rotate. So I'll bring in the guard for each of these and look at the move and rotate. And and I don't have anything to set the movement speed, so I'll go ahead and add that right now. Public void set move speed float move speed this dot move speed equals move speed. Alright, and now I can select this move and rotate, set move speed, so when it starts chasing I'll go at a speed of 4, and when it returns to its patrolling state, then I will set the move speed back down to 2. And then I'll, no, not that. Then I'll go on to this prefab, apply those changes, and let's see this in action. So the guard is chasing me and it's moving kind of fast. I have a hard time getting away from it. Okay, then it lost track of me and now it's going nice and slow and it's on its patrol path. Sees me again and speeds up. I can hide behind a wall, but it's a little difficult to escape because of that extra time. Now it lost me and now it's walking back to its path again. Okay, so now we have a full guard that is able to both chase and patrol and dynamically switch back and forth between them. It can also detect a player by giving it a little bit of artificial vision. And yeah, that's all for today's lesson. It's running a little bit long. Next time, we're going to be adding some finishing touches to this little prototype game, such as some win-loss conditions. Thank you very much for watching, and I will see you in the next one.